on a right triangle, let's pretend that this angle right here, we know this angle. Let's pretend we know this angle. How do you measure angles? Thank you. That's how we're going over this. So let's say we know for sure this is 60 degrees. By the way, it's on a unit circle. So if that's 60 degrees, then what's the radians? Pi over 3. Okay, so remember, these are angle measures. Remember, those are angle measures. What if I asked you to find, remember SOHCAHTOA? Let's just focus on these real quick. Remember, if it's on the unit circle, we know the hypotenuse is 1. So if I asked you for sine, remember sine is opposite over hypotenuse. The opposite is this measure right here on a unit circle. So remember, this is going to be how high up it is. It's a y value, which is going to be, I don't know, what's the sine value of pi over 3? 1/2. This value right here is a fraction. It's a ratio. Not radians, because it's not a degree. Not angles, because it's not a degree. So you're going to have to remember that because you're learning brand new stuff and a brand new set of instructions. So I just wanted to make sure we were all clear on that with that little baby example. All right, now let's go back to page 33. Please go to page 33. If you were already there, good for you. I'm not there, but I'm about to be there right now. Okay. So on page 33, before we look at this box, let's go ahead and answer this question up here. Oh, we got a little true-false number sentence. These are always fun. Let's go ahead and look at this part right here. Does cosine of 30 plus 60 in parentheses, does that equal whatever cosine is plus cosine of 60? Let's find out. Can you combine what's inside parentheses there? Yeah. So, does cosine of 90 equal cosine 30 degrees plus cosine 60 degrees? I don't know. Let's find out. What is the cosine value for 90 degrees? Top of the circle. It's 0. Remember, cosine is 0. Okay. And then 30 degrees is a little baby angle. It's the smallest radians. What radians match 30 degrees? Pi over 6. What's the cosine value for pi over 6? Root 3 over 2. Plus the cosine value for 60 degrees. It's 1 over 2. It's pi over 3. That's why y'all have your little unit circle. Is that a true number sentence? Does that equal that? No. We wish it was that easy, but it's not that easy. Things are way too involved in pre-cal for it to just be that easy. So what we have to do is we have to use some more properties and some more identities for the unit circle. This is going to be given to you. I'm going to just copy and paste this on your quiz and test, but I'm not going to tell you how to use it, and I'm not going to tell you how to identify it. Let's take a look at what's going on here. Let me give you some tips. All right. So first of all, over here on the left side, notice everything has parentheses on the left side of the equal sign. That's condensed form. and it always has parentheses. On the other side of the equal sign, it's not condensed. It's really long. It's expanded form. But here's what you need to remember. Obviously, this is a cosine identity because it says cosine. I know that's a cosine. If I covered this up, I still know that's a cosine identity because cosine is written first. So in expanded form, on the other side of the equal sign, whichever trig function is written first is part of the identity. So without looking at the parentheses, I know that's a cosine identity, I know that's a sine identity, I know that's a tangent identity. Something else that you have to remember is cosine is a big fat liar. So if you notice, see how cosine has a plus sign in there, but it has a minus sign in expanded form. You're going to have to remember that. Over here, cosine has a minus, but in expanded form, it's a plus sign. So you have to remember that too. Also, I don't know if you guys know these titles. This weird looking A, that's called alpha. This weird looking B, that's called beta. That just means the first angle printed. Alpha is the first angle printed. Beta is the other angle. That's all that is. One more tip, which is the best piece of advice I can give you for a 5.4. Look for parentheses. If parentheses are printed on the problem, then you're working in expanded form, the other side of the equal sign. If there's no parentheses printed on the problem, then that's what you need to work on. You need to work on parentheses. So whichever is there, you're working in the opposite direction. And then let's go ahead and talk about all these different directions. So you have these brand new properties that you need to be responsible for. And you have brand new sets of directions. Let's look at this direction right here. This says verify. Y'all know what verify is. It was just like your exit ticket. It makes one side look like the other. Still the same stuff, you know. Make one side. Ooh, I can't spell. Make one side match the other. Remember, that's what verify means. We've been doing that this whole time we've been in chapter 5. Here's another set of directions. This says simplify. That means write as a single expression. A monomial. One term. One term is what I should write on there. Let's look at this down here. Numbers 4 and 5. Write the expression as the sine, cosine, or tangent of a single angle. How are angles measured, y'all? What's the two ways you can measure an angle? Radians and what else? Yes. So your answer, if it starts in radians, it stays in radians. If it starts in degrees, it stays in degrees. Degrees or radians only. All right, I'm going to turn my page. I think y'all just have to scroll your eyeballs over to the other side. What else do we have to do? Ooh, these are my favorite. Find the exact value. I should have wrote, but it's implicit. Find the exact trig value. Sine, cosine, tangent. Sine, cosine, tangent are not degrees. You better not have radians in your answer. You better not have a degree symbol in your answer. Those are just expressions. So no radians, no degrees. If you did that, you did something wrong. So, all right, cool. Let's get started. So fun. I can't wait till we get to page 34. That's where the fun begins. But let's go ahead and go back to page 35. Okay. All right. So number 1 says to verify. And remember, we just talked about how to make one side look like the other. Look at number 1. Do you see parentheses? Yes, you do. So you're going to work on the other side. You're going to make it look like expanded form. So, guys, I'm sorry, I can't. There's just not enough room, so I have to go to a separate sheet of paper. Why do we what? Because it's obviously not in, like, does this side match that side? Because if it's in parentheses right now, I'm stuck. I don't really have any way of making it match this side. These are no, remember at the top of the paper, remember the cosine of this plus the cosine of that does not match what the cosine is. Good question. All right. So this is a cosine identity. Cosine always starts with cosine. And it's going to be cosine alpha times cosine beta. Remember, cosine is a big liar. So if that's a plus, I'm going to write a minus. And then it's going to be the sine alpha times the sine beta. What if it was what if it was Friday and you saw this and the only instructions I gave you were verify? You're going to know what to do because you see parentheses. When you see parentheses, you go to these identities at the top of your paper. Okay, so please remember this is alpha. So we're going to find cosine of pi first. Here's alpha again, so I'm going to put pi here. And then beta is the other one. So beta is going to be this, which is x. All right. Do we know anything? Yes, y'all. Y'all know sine. You know cosine of pi and you know sine of pi. So let's drop those in. Yeah, what's cosine of pi? Y'all know that. -1, okay. Times cosine of x. I don't know what that is. So just like a regular variable in any equation, you just leave it. I'm going to bring down that minus sign. What's sine of pi? Times sine x. I don't know it. And then you have to know your order of odds. We're going to multiply those. We're going to multiply these. Then we're going to subtract them. But you should already know the answer because 0 times anything is 0. So -1 times cosine x is negative cosine x. Minus 0 leaves that. And then look, we just verified it. We made the left side look like the right side. Done. So that's how we verify using these trig functions. Let's do it again. Let's look at problem 2. So for problem 2, we're verifying. Quiz on Friday, I just say verify. What are you going to do? How are you going to know what to do? You might want to try to factor first. For real, I might want to try to factor. But look, see how these are different numbers? These are alphas and betas. That's what you're going to pick up on Friday when I ask you to verify this. These don't match. Neither do these. So we know, do you see parentheses? So we know we're going to put it back in parentheses. The first thing I see is a cosine. Okay, I know I'm going to be working with a cosine, whatever. Know that for sure. Please remember, cosine is a big liar. So if you see a plus sign, you have to write a minus sign. What's alpha? I don't know. What's the first thing that you see after cosine? 3x. That's alpha. What's beta? The other one that doesn't match 3x. What's the other one? 2x. Can you combine those? Those are like terms. What's 3x minus 2x? when there are not parentheses, don't overanalyze how easy this is. That's all it is. When there's no parentheses, that's all it is when I ask you to verify. Done. Okay, that's verified. One side looks like the other. Next one. Simplify. Obviously, I can't verify there's no equal sign. You only verify when there's an equal sign. Simplify means you're going to write this as a single trig expression. Cool. Let's do that. Let's pretend it was Friday, and it just said simplify. How are you going to know what to do? How are you going to know it's a trig property? Okay, it's sign. Okay, cool. We know it's a sign property for trig. I mean, a sign property. Cool. I'll write that. But what else? Like, what do you know? Like, y'all, we know a lot of stuff about sine. We know sine squared plus cosine equals 1. We know a lot of stuff about sine. How do you know what to do next? There's parentheses. Very good. Y'all, look in parentheses. Can you combine those? Are these like terms? Then you know for sure you got yourself an alpha and a beta. So they don't match, so you have to use the difference property. All right, here we go. It is going to be sine alpha times cosine beta. I'm just recopying the property. I like sine. Sine's not a liar. So if that's a minus, this is a minus. And then it's going to be cosine alpha sine beta. Sine always starts and ends with sine. They're bookends. All right, cool. Can we plug in some actual numbers? We can. Guys, y'all know the sine value for pi over 2. Remember, pi over 2 is at the top of the unit circle. So what is it? It's 1. Good. So let's put a 1 in there. We're going to multiply it by the cosine of beta. Oh, there's a variable. So all you can do is write cosine x. Cosine beta is cosine x. Bring down the minus sign. And let's take a look at what's going on over here. Cosine of alpha. Cosine of pi over 2. You know that. What is that? It's 0. It's at the top of the unit circle. Good. Times sine beta. Oh, that's an x. So again, all you can do is write that. That gets wiped out completely. 1 times cosine x minus 0. This is just cosine x. This simplifies to just cosine x. Any questions on that?